Hello. We are from Ukraine. In this episode, we will discuss how spy games in our brains are different from those in movies. Artificial general intelligence is a model of natural intelligence. While modeling, we are following the great advice from Albert Einstein. We need to come up with a model that has all the essential components of natural intelligence and handles them in the simplest way possible. Luckily, humankind has already developed such a model. It's a language. We only need to apply it properly. Let's start by analyzing what makes language a perfect model for natural intelligence. Even if the world is imaginary as in the books about Harry Potter, language allows describing it in whatever level of detail necessary. A translation of the description into a different language loses little information if any. Given any scene, language can describe its initial state, actions that modify it, and its final state. Language allows assigning symbols to what is hard to describe, like sensory signals or abstractions, and relating those symbols to objects and actions which we can sense or imagine. Objects have properties, actions modify properties. That makes properties an important component of the world and any of its models. Language has rich tools for handling properties, objects, and actions. When different people describe properties, objects, and actions, they may use different words to refer to the same observable pieces. Hearing those different descriptions, other people correctly understand what pieces stand behind those references. Deception or confusion are possible but only speak in the favor of language. Considering the Turing test, experts only deal with the exchange of text messages. Those messages carry enough information to conclude whether or not an agent on the other side is intelligent. We are not going to prove that there are no simpler tools. Let's just proceed with the analysis of language. Considering sentences as formulas, we can view constituents as formula components. But these formulas are not mathematical, they are more like physical ones. Distance is speed multiplied by time. Each element of the formula has its own characteristics. Knowing any two, we can calculate the third one. But that's not how our brains work. There is no use in the calculated value. Forget about formulas. Our brain picks eligible pieces among available ones and one by one substitutes them for the unknown piece and checks how fitting that one is. The most fitting one wins. It is more like looking for a new employee instead of the one who just quit the company. A missing piece is not available. But we have a job description to which the best candidates should match as much as possible. That is what our brain does, it matches candidates to roles. We know how easy it is to refer to an object which is one of its kind. When there are many, we need to provide additional references. Sometimes referring to the exact object is too troublesome. In such cases, we use shorter combinations even if they invite clarifying questions. Constructing references is not science, which is why different people may come up with different descriptions for the same objects. To understand a message, we need to figure out what each reference refers to. In the case of complex and vague references, it may be troublesome. The best candidate will demonstrate the best match across all the references. Our brain knows how to pick properties. But property is more like a scale, which can be used for measurements and against which comparisons can be made. The easiest way to differentiate objects is to have three options: average, above average, and below average. If that is not enough, we can add narrower ranges: intermediate, upper intermediate. We can reach even higher accuracy by assigning numeric values to points on a scale. While assigning labels, our brain uses all those approaches simultaneously, so it's a funny-looking scale. The world is chaotic. Our brain tries to rule over the chaos by bringing order, by measuring and comparing. We learn about new objects and how to generalize them. We may use the same word to mean different things and learn how to understand what that word means given a context. We acquire knowledge about the world and use it in further interactions with it. We reason about the root causes of events and plan our steps for achieving our goals. We reach out for anything new because it enriches our knowledge with more information. We dive into abstract realms using tools from the material world as metaphors for abstract concepts, as handles for using them. Let's analyze how well this definition fits with different kinds of intellectual activities. Imagine a kitchen full of different items. Imagine a mother pointing somewhere and saying, "Look, there's a chair." A child has no way to connect the word chair and one of the objects in front of her. The mother then asks the father, "Honey, bring in another chair." The child observes the father bringing in another object, which is now surely a chair. The child then searches the kitchen for a similar object, Even if kitchen chairs are different from the one brought in, the most fitting candidate will be found. One more thing will occur: the child will learn to generalize. Those two objects are different, but they are still chairs. This feature of language is where statistical approaches fail most often. On a hot day, one may eat a hot pepper and look at a hot girl. The same word hot refers to three different properties. The bag of words will make lots of silly mistakes based on that sentence. People, on the other hand, know well that days may not taste spicy, peppers have normal temperatures, people in swimsuits do not go to financial institutions, and so on. Language, through the mechanism of references, allows for figuring out not only which properties apply to which objects but also which meanings of words resonate the most in a given context. From childhood, we learn about the results of different actions. Consider results as changes in properties. Then we may represent knowledge as formulas: object A as property B, or action A changes property B. Observing pieces of those formulas, we will know how to figure out what is missing and what piece will fit the most. If we need to achieve a specific change of specific properties for specific objects, we will go over known formulas involving those properties and objects. Based on our previous experience with actions mentioned in those formulas, we will design a plan for reaching our goal. Splitting a big task into smaller manageable tasks is only natural. Given observable results of unknown actions, our formulaic knowledge allows reconstruct past events. This reconstruction is different from backward propagation. We make assumptions and estimate how fitting they are. Formulas explain very well why an alibi is so important for detectives. Optimal guesses in the game of bulls and cows provide information that allows winning a game in at most 7 moves. Each guess eliminates possible secret combinations. The best move not necessarily eliminates most, but it provides the most information. When we observe an event providing a lot of new information, we are fascinated by it, and we remember it. Alternatively, we may initiate experiments that promise to generate new information. Consider such an abstract concept as value. What is more valuable, apples or bread, apples or pencils, apples or letters from friends? The price is definitely not the same, but it allows for measurements and comparisons. Having handles for abstractions makes it easy to process them. As a house of arbitrary complexity can be built from bricks, our knowledge consists of formulas that can be combined to form new concepts. Given a formula for a new concept, we can ask questions about any of its pieces. Not all of them have to be present, and this makes formulas flexible. This way we may address the unlimited with a limited toolbox. In this video, I introduced formulas or definitions that enable all sorts of intellectual activities. You can help me with your likes and comments. And don't forget to subscribe and push the notification bell to be informed about upcoming videos. New videos will follow in the future. Your attention will be much appreciated.